Hello, class. So, today we're going to be talking about System Development Life Cycles, or SDLC for short. Now, what is SDLC? Well, of course, I could just Google it and find myself an answer, but I'm just going to paraphrase this. SDLC is a development cycle. It is a series of steps for different projects, and different types of projects require different types of steps to be used. And as much as we would love for there to be one step or one process that would actually fix everything, in the real world that's not the case, because not everything you need to do is exactly the same way. So, I'm going to use an example of probably the most basic type of structure you've ever used. So imagine you're in high school, or middle school, or even elementary school. When you were writing a paper, what was always drilled into your head? Well, you start with your outline, then you go into your rough draft, and then you do edits, and then you present your final copy, right? You go step 1, step 2, step 3, step 4. And this is what is known as the waterfall model. And if we take a look at the waterfall model, we take a look that it has, step 1, step 2, step 3, step 4, step 5, step 6. Now, of course, the actual things that you put in here are, depending on what company you work for, depending on what process you're actually using. As you see, some of them even, have things that go back up, and depending on different processes, there's nested waterfalls, there's other waterfalls that wind up having little mini steps inside themselves and little checks and balances. But for the most part, the simple idea is that you have step 1, step 2, step 3, step 4, step 5, step 6, so on and so forth. This is by far probably the simplest concept in all of SDLC. Now, what are some of the advantages of this? Well, it's easy to figure out. It's easy to understand. Are we in step 3? No. Are we in step 4? Yes. Okay, I guess we're doing step 4. So on and so forth. What are some of the downsides of this? Well, what happens if we make ourselves all the way down to the final step and then realized, oh no, we screwed up something in our planning? Well, then I guess everything we did was for nothing, right? I mean, is this the type of process you would use if you had a 20-year project you were making? Probably not. Is this something you would do if you have a really quick time frame and, you just need to pump something out? Maybe. But even already you can see that you're probably not using this for everything you're using. Do we understand the concept so far? Then let's move on to another DLC. Not DLC. But you know what? Since we're talking DLC, let's talk video games. So instead of having a project where you're going step 1, step 2, step 3, step 4, step 5, step 6, what happens if you have some sort of project like Overwatch? Or some other sort of game where every couple of months you're just giving out a new content, or a new character, a new level, a new power-up? What about your phone apps? You ever notice how every single day or so, one of those apps winds up having yet another update? It's just a constant stream of updates. Is this ever going to physically end? Really not. There's always going to be a new software update, more bug fixes in some of these products. So having a system that has a definitive end state probably is not going to be the thing you want. So what would you want if you wanted something that would essentially never end? Well, that's where the spiral model comes in. And, oh, lovely picture there. I'll pick this one. And let me just zoom in a bit on that. So imagine here we have this little line. It's just going around in a circle, around in a circle, around in a circle, getting bigger and bigger and bigger and bigger and bigger. Now, taking one look at this, it kind of doesn't make much sense. So, imagine this line, this curly line, is money, and it's also time. Now think about it. Every single time you have your phone update, and then every single time they go and fix bugs, make new processes, fix bugs again, release a new update, so on and so forth, they're costing money, they're costing time. They have to pay people, they have to take the time to code the machine, so on and so forth. You're constantly, the further you get away from center, the more money you're spending, the more time it's taking. And of course, how does that always wind up going? Well, what do we want to do? Now let's build it. Now let's ship it out. Now let's review it. Okay, what worked, what didn't. Now let's go and build it. Now let's go and ship it. Now let's go and see what worked and what didn't. It's a constant cycle of essentially the same 4 steps over and over and over and over again. Now, you would use something like this if you had a phone app, because you're constantly updating it and you're constantly checking what worked and what didn't, adding new features, taking some away, fixing bugs, fixing problems, so on and so forth. And of course, at some point, like this graph just has it here at this line, this is where the prototypes, these would be the actual physical releases. Here's a release, okay, back and forth, back and forth, back and forth. Now here's the next release, so on, so on, so on, so on, so on. There's the next release, so on, so on, so on, so on. There's the next release, and it would essentially keep going on and on and on and on and on, adding on to infinitum. Now this particular graph ends with a physical release here, which, you could eventually have an end date. At some point in the distant future, it will become too expensive to keep updating the same program over and over again. You will at some point have to physically say, no more, we're not going to be updating any more of this old legacy code. We're going to have to start from scratch on an entirely new project. Even your Windows computers, at some point, they ditched all the old architecture and started anew. At some point it will happen, but in the foreseeable future, the process is never ending.